GCSE Forces Lesson 11, and this is momentum and explosions. So the objectives, the first thing we're going to do is a momentum calculation for a head-on collision, which we talked about at the end of lesson 10. And then we're going to make calculations of explosions where linear momentum is conserved. Interesting GIF, if you want to look it up, it's the SpaceX when they were doing testing the rockets, trying to get the reusable rocket tech to land. Lots of failure, catastrophic failure. Company nearly went out of business before obviously they've had the success that they've had today. So what we're going to do is start with this one. So it's basically the same question as what we did at the end of lesson 10, but this time they're heading towards each other, so we're going to find out what happens. If you want to have a go at it, all I want you to think about is the fact that momentum is a vector and it must have direction. So you've got positives and negatives for the direction. So if you want to have a go, please do, and then I'll take you through the answer, which I will do now. So what we need to do is to make our table. And remember, it's the momentum before. The momentum before the collision is equal to the momentum after the collision, which is the basis for the conservation of linear momentum. So first of all, we've got a train wagon of mass 8,000 kilograms moving at 4 meters per second. So we need to do that momentum. So 8,000 times 4. And it collides and remains attached to another wagon of mass 12,000 kilograms that's moving in the opposite direction. So if it's moving in the opposite direction, obviously with this first one, we took right as positive, but if it's traveling in the opposite direction, we need to subtract the momentum of the second wagon, so that would be 12,000 times 3, so minus 12,000 times 3, put that in brackets, equals the momentum after. Well, it says calculate the common velocity, so that means that they would have attached together, the wagons. So we need to do 12,000 plus 8,000 kilos gives us a total mass of 20,000. And then we need to times that by v, the unknown common velocity. Then we just need to figure it out. So the first one, 8,000 times 4, is simply 32,000. This time minus, we've got 12,000 times 3, which gives us minus 36,000, equals 20,000 v. So it's not going to be moving very fast, and you'll see why. So we've got 32,000 minus 36,000, which is minus 4,000. We'll see what that means in a minute, equals 20,000 times v. So v is simply minus 4,000 divided by 20,000. So that gives us minus 0.2 meters per second. And what that negative means is that it's moving to the left. So when these, when the wagons come together, they're going to move off to the left after the collision at minus 0.2 meters per second. Hopefully that's okay. Let's move on to the next one. So on this one, we're going to look at explosions. So before an explosion, the total momentum is 0. And as the momentum is conserved, the total momentum afterwards must also be 0. This means that the different parts of the exploding body must move in opposite directions. So as you can see with this gun, it looks like an artillery piece. The shell would fire out in this direction and have momentum, which could be anything. It could be plus 1,000. And then the artillery will move back in this direction with a momentum in the opposite direction of minus 1,000. But as you can see, plus 1,000 minus 1,000 is equal to 0 as it was before. Okay, so when we do the maths, it's pretty straightforward. So let's have a look at some questions. So an artillery gun of mass 1,500 kilograms fires a shell of mass 20 kilograms at a velocity of 150 meters per second. Calculate the recoil velocity of the gun. It's quite straightforward. So the momentum, what I would write is the momentum of the gun is equal to the momentum of the shell. Now, one of these can be negative. It wouldn't be the end of the world if it wasn't. So the momentum of the gun is the mass times the velocity. So it's the mass of the gun. So that's 1,500 multiplied by the velocity of the gun, which is what we're trying to find out. So I'll call that Vg, equals the momentum of the shell. So the mass of the shell is 20 multiplied by the velocity of the shell, which is 150 meters per second. So then it's just a matter of doing the sums and making v the subject. So on the right hand side, we've got 20 times 150, which is 3,000. So we've got 1,500 lots of Vg equals 3,000. So the velocity of the gun, we need to get rid of the times 1,500. So obviously to get rid of a times 1,500 to the other side, we have to divide by 1,500. So the velocity of the gun, is 3,000 divided by 1,500, which gives us 2 meters per second to the left. Or if you were taking right as positive, you could say that your answer is negative 2 meters per second. And the negative is just indicating that it's going in this direction. Hopefully that's okay. Let's do another example. Bit of a strange one, but if you want to have a go at this, let's pause. Exact same as last time, but obviously a different scenario. A girl of mass 60 kilograms throws a boy of mass 90 kilograms. Whatever boy that size weighs 90 kilos or has got a mass of 90 kilos. I know it looks a bit strange. Out of a swimming pool at a velocity of 2 meters per second. What is the girl's recoil velocity? So we're going to do the momentum of the girl is equal to the momentum of the boy. So momentum of the girl would be the mass times the velocity. So the mass is 60 kilograms multiplied by the velocity. I'll just put velocity of girl equals the momentum of the boy. So that's mass times the velocity. So that's 90 times 2. So then we just need to figure it out. So we've got 180 on the right hand side and then 60 lots of Vg on the left hand side. So the velocity of the girl, we need to get that on its own, make that the subject, Vg. So we need to get rid of a times 60. So we need to divide by 60. So Vg will be equal to 180 divided by 60. So the recoil velocity will be 3 meters per second. Now if you were taking the boy's momentum, is positive, the girl's is negative, then you could write minus 3 meters per second. Hopefully you got that one right. Let's move on. Right, if you want to pause and have a go at this. So the figure below shows a skateboarder jumping forwards off his skateboard. The skateboard is stationary at the moment the skateboarder jumps. The skateboard moves backwards as the skateboarder jumps forwards. Explain using the idea of momentum why the skateboard moves backwards. So this is all about the conservation of linear momentum. I'm going to put the mark scheme up now and you can check your answer against the mark scheme. So yeah, the idea of the momentum before jumping being equal to the momentum after, both is 0. So momentum of the skateboarder is 0. And after jumping, the total momentum is still 0. And that's because we've got some forward momentum of the skateboarder, yet we've got an equal yet opposite momentum of the skateboard. Something along those lines. And if it was mathematical, you know, the momentum of the skateboard, whatever, let's say it's 20, will be equal to the momentum, you know, of the person, but one of them would have to be negative. So equal momentums, opposite directions. Let's do a calculation. If you want to have a go at this one, and then I'll take through the answer now. Right, okay, so we've got a mass of the skateboard, so we've got 1.8 kilograms. And the mass of the skateboard is 42 kilograms. Calculate the velocity at which the skateboard moves backwards if the skateboarder jumps forwards at a velocity of 0.3 meters per second. So, once velocity of the skateboard, so we're going to do the momentum of the skateboard is equal to the momentum of the skateboarder. So I'll call it P for person. So the skateboard's mass is 1.8. So we've got 1.8 multiplied by the velocity. We'll call this side negative as well. We'll just make our answer negative at the end, equal to the momentum of the person, so that's 42 kilograms multiplied by 0.3 meters per second. So to the right, that's 12.6. And then we've got 1.8 times V. So V would simply be, we need to get rid of the times 1.8 to make V the subject. So we need to divide by 1.8, so that's 12.6 divided by 1.8. So if you put that on your calculator, 7 meters per second. And remember we said that it would be negative, so you could write minus 7 meters per second. Hopefully that went okay. I hope you found that helpful. Thanks for watching, and I will speak to you at the next video.